The curve with equation y equals e power 2x over x cubed has one stationary point. Find the coordinate of the stationary point. So for at the stationary point, we know that dy by dx is equals to 0. We're going to derivate this using the quotient rule and equate it to 0. So using the quotient rule, derivate the numerator first, which will be 2e power 2x times x cubed, minus sign in between, derive the denominator and multiply the numerator with that. So numerator is e power 2x. Derivative of denominator would be 3x squared. And in the denominator, we square the current denominator, the original denominator. So it's going to be x power 6. All right. So x power 6 goes and multiplies with 0, eliminates. Here we can take e power 2x common and x squared common. So we get 2x minus 1 equals 0. We get x squared equals 0, or e power 2x is equals to 0, or 2x minus 1 is equals to 0. Okay. This gives us a math error because if we send e to the other side, we get 2x is equals to ln 0, which is a math error, so no solution here. This one gives us x equals to half, and this one gives us x equals to 0. Obviously, x cannot be equals to 0 because that will make the the equation of the curve undefined. We cannot have a 0 in the denominator, so you write no solution or undefined with this as well. So x is equals to half is our only correct answer. I'm so sorry, this was 3, and this is 3, and this is 3. So x equals 3 by 2. Okay, part 2, determine whether this point is a maximum or minimum. All right, for maximum and minimum, mostly we double derivate, but double derivating this is so much hassle. So instead, what we'll do, we'll look at the stationary value, which is x equals to 1.5. What we'll do, we'll take a small value, a value smaller than it, which is 1, and a value slightly bigger than it, which is 2. Now we're going to substitute this in dy by dx. So we'll find dy by dx when x equals to 1, and we'll find dy by dx when x is equals to 2, and then look at the signs of the dy by dx, and from those signs we'll be able to tell whether it's a maximum point or a minimum point. Okay, so if we substitute x equals to 1, we would get a negative value, minus 7.289. And if you substitute x equals to 2, you'll get a positive value, 3.412. So what's happening, if this is your stationary point where x is equals to 1.5, before that the derivative is negative. So that means the curve is decreasing. That's why the gradient is negative. And on the other side, the gradient is increasing. That's why dy by dx is positive. That makes this a minimum point. So since dy by dx is less than 0 for x is equals to 1, and dy by dx is greater than 0 for x is equals to 2, hence minimum point. So we do not have to double derivate this and then substitute x is equals to 1.5 in it and then show that we're getting a value greater than 0 and hence write a minimum point. That is too much hassle. You're likely to get it wrong. So it's better to do it this way.